Okay, so let's take a look at 4.4, simplifying algebraic expressions involving exponents. And what we're going to do is apply all of our exponent rules, everything that we've learned so far, but we're not going to try to get out of hand and try to do too many things at once. We're not going to try to change any negatives, exponents and all that stuff. We're not going to take seventh roots of things. What we're going to do is simplify first, and then the final answer we will simplify accordingly. So let's look at letter A. Over here we have s to the power of 7 times s to the power of negative 5 all to the 3. Now, please don't go and change this to 1 over s to the power of 5. Okay? What you want to do is simplify this stuff first, and then simplify your final answer. So what I'm going to do first is actually the power of a power rule here, because multiplication comes before addition. Multiplication rule would be adding the exponents. Power of the power is multiplying exponents, so that's what I'm going to do first. This is s to the negative 5 all to the 3, which is s to the negative 15. And then if I do s to the 7 times s to the negative 15, the multiplication rule states to leave the base the same, add the exponents, so that will be s to the negative 8. Now, your final answer cannot be written with a negative exponent, so I will now write this as this is the same as 1 over s to the positive 8. So this is your final answer. Let's take a look at B. B has all this stuff mixed up. I'm going to try to do one thing at once, not everything at once. So the bottom I'm going to leave as this because there's nothing to be done here. But at the top, as you can see, you have all this to the power of negative 3, and then all to the power of negative 2. So you have a couple options here. You can deal with this power of a power right now if you wish, or you could deal with everything inside and then square everything afterwards. It's up to you. What I'll do actually is take care of this power of the power. See, it doesn't matter all this stuff. I'm going to rewrite this stuff as 3g squared h, but this power of a power, it asks us to multiply these powers together, so negative 3 times 2 is negative 6. I'm not going to divide anything yet because these are all powers of powers right now, so I'm going to continue with the power of power. So I'm going to end up with, on the bottom, g to the 3, h to the negative 1. And on the top, just remember this negative 6 applies to all three things here. This is just one item being multiplied together, but this is 3 to the negative 6, g to the 2 to the negative 6, and h to the negative 6. So that's what I'm going to write. 3 to the negative 6, so I've applied the negative 6 there. G squared to the negative 6, that's a power of a power, so keep the base as g, but 2 times negative 6 is negative 12, since that is g squared all to the negative 6, power of a power. And then I have h to the negative 6, so I've taken care of all three of those items. Continuing this, I'm going to leave my 3 to the negative 6 right now because there's nothing to divide it by. But my g to the negative 12 divided by g to the 3, I can do that. That's division rule. Keep the base the same, subtract the exponents. Negative 12 minus 3 is negative 15. And then I have h to the negative 6 divided by h to the negative 1. Be careful there. Keep the base the same, subtracting the exponents. You have to be careful. This is negative 6 minus negative 1. So negative 6 minus negative 1 ends up being negative 6 plus 1, which is negative 5. Now, this is not my final answer. Now my final answer, I have to rewrite this in proper form. I cannot have any negative exponents. So anything with a negative exponent will go to the bottom of this fraction. So this 3 to the power of negative 6 is the same as 1 over 3 to the positive 6. G to the negative 15 is the same as 1 over g to the positive 15. I'm not going to write the 1 again. 1 times 1 is 1. And h to the negative 5 is the same as 1 over h to the positive 5. And of course, this is my final answer, unless you want to actually write down what 3 to the power of 6 is, which is 3 times itself 6 times, and that's okay to write at the front there. Let's take a look at question C. Again, I'm not going to go start trying to rewrite my negative exponents as fractions. I'm going to first take care of my multiplication rules, division rules. My final answer is when I will take care of a negative exponent. So over here, On the bottom, I'm going to leave this alone as 3x squared y to the power of negative 4. But at the top here, I'm going to do this times this. This is one item times one item. So this item here, negative 6x to the power of negative 2y times this item here, how do I multiply those together? Well, negative 6 times negative 9 is positive 56, and sorry, positive 54. And I have y to the negative 2 times y to the negative 5. How do I do that? I multiply the two bases that are the same. You keep the base the same and add the exponent. So negative 2 plus negative 5 is negative 7. And then multiplying y to the power of 1 times y to the power of negative 2. Again, keep the base the same, add the exponents. 1 plus negative 2 or 1 minus 2 is negative 1. Continuing this, now I will do my division here. So you got to remember here that you have 54 divided by 3, you have this x as a base divided by that x as a base, this y as a base divided by that y as a base. Okay? So I have 54 divided by 3, and if you do 54 divided by 3, it's 18. I have x to the power of negative 7 divided by x squared. Again, how do I do that? Keep the base the same, subtract the exponents. Negative 7 minus 2 is negative 9. And then I have y to the negative 1 divided by y to the negative 4. Be careful here. Keep the base the same, subtract the exponents for my division rule. And so I will have negative 1 minus negative 4 actually becomes negative 1 plus 4, which is 3. Now continuing this, none of my bases can have negative exponents on my final answer. So the 18 is okay, and so is the y cubed. What is not okay is x to the negative 9. So I'm going to rewrite that as 1 over x to the positive 9. Notice I didn't write the 1 out up top because I already have an 18 and a y cubed. So it's just going to be 1 times that stuff, so I'll just leave it as is. So this is my final answer. Let's take a look at this one here. Okay, so before we start doing square rooting and seventh roots and all that stuff, let's see what we're dealing with. We have x to the power of 14 all to the power of negative a seventh on the top, and we have the square root of x to the power of 6 on the bottom. So I'm actually going to do this power of a power, and when I do that, this is x to the 14 all to the negative 7. 14 times negative a seventh is negative 14 sevenths. You do that on your calculator. And over here on the bottom, I'm going to rewrite this. I'm going to leave the 6 there, but that x, the square root of x, I can rewrite as x to the power of a half. Continuing this, on the top, I have x to the power of negative 14 divided by 7 is negative 2. And on the bottom, I have x to the power of a half all to the power of 6. How do I do that? Keep the base the same and multiply half times 6, which is 6 halves, or a half of 6 is 3. So that's a power of a power. That's all I did there, 3. And continuing this, now that's the division rule. And the division rule states if I'm dividing two bases that are the same, keep the base as x and subtract the two exponents. Negative 2 minus 3 is negative 5. And that's my final answer, but I cannot have my final answer with a negative exponent, so I'm going to write that as 1 over x to the positive 5. That's the same as x to the negative 5. That's my final answer. Let's take a look at question E. So question E, there's a couple ways of doing this one here. We have 25 y to the power of 4, b to the power of 6, all to the power of, and I can rewrite that as a half if you wish. Or you can leave it as 0.5, but I'm actually going to write it as a half, so I'm going to just rewrite this exactly how it is, except this is the power of a half, and I'm going to rewrite this exactly the same as this is, except that is a quarter, right? 25 cents is the same as a quarter. So, continuing to do this, we're going to do all this is to the power of a half, so that's 25 to the power of half, a to the power of 4 to the power of half, b to the power of 6 to the power of a half. So I'm going to write that. So this is 25 to the power of a half, that half applies to the 25. A to the 4 to the half, That is a to the power of, that's a power of power. 4 times a half is just 2. And then b to the 6th of the half, that is a power of a power also, so leave the base the same. 6 times a half is 3. Continuing this, over here, this is all these things to the power of a quarter. So I have 256 to the power of a quarter. I have a to the power of 8 all to the power of a quarter, so I'm going to leave the base as a. 8 times a quarter is just 2, or 8 quarters, which is 2. And then I have b to the 4 to the quarter, so I'm going to leave that as b, and 4 times a quarter is just 1, so I'll leave it like that. Continuing this, that 25 to the power of a half is the same as the square root of 25, a squared b cubed. And this 256 to the power of a quarter is the same as the 4th root of 256, a squared b to the power of 1. Continuing that, the square root of 25 is just 5, a squared b cubed. And over here, the 4th root of 256 is 4, because 4 times 4 times 4 times 4 is 256, a squared b to the power of 1. And then continuing this, I can do my multiplication between these two things. 5 times 4 is 20. A squared times a squared, I'm going to leave the a the same, add the exponents to be 4. And b cubed times b is b to the power of 4. Add the exponents, keep the base the same. So this is my final answer. Last question is question F. So if I take a look at question F here, again I have y to the negative 4, x to the 3 all squared here. I have x to the 1, y to the 1 all to the negative 3. And on the bottom I have not really a lot going on here, so I can't do any of that stuff. I'm going to simplify the top first. So over here we should know that I can apply this squared to both of these things in here. So this is y to the negative 4 all squared, which is the same as y to the negative 8, because that's a power of a power. Negative 4 times 2. And then this is x cubed all squared, so that's the same as x to the power of 6, power of a power, multiply them. Then over here I have x to the negative 3 and also y to the negative 3. That's just also that power is applied to both of those things. Continuing this, I'm going to use my multiplication rule over here. So this is going to be y to the negative 5, x to the negative 3 on the bottom, but I'm going to multiply these things together. So let's take a look at the y's first. Y to the negative 8 times y to the negative 3. I'm going to keep the base the same, add the exponents, because multiplication, negative 8 plus negative 3 is negative 11. Then I have x to the 6 times x to the negative 3. Again, keep the base the same. Multiplication rule, add the exponents. 6 plus negative 3 is 3. And then I'm going to divide these two things together. So dividing